Welcome back to International Finance. I am Andy Kim, your Dr. Finance. This video we are going to discuss Appendix A of Chapter 6 in Un, Resnick and Chulun's International Financial Management, 9th edition. And this is about purchasing power parity and the exchange rate determination. Why do we need this appendix? Because international finance is heavily based on macroeconomics. Right? I told you finance, right, is a subfield or applied field of economics, right? And then the international finance, it's about foreign exchange rates, and then what is the force behind this FX movement, right? We learned about IRP and PPP and international parity relations like that in this chapter. But remember, a lot of that resorted to the economic fundamental concepts like interest rates and then inflation rates, right? It has a lot to do with monetary supply and those monetary economists idea, right? The purchasing power parity can be viewed as a more profound economic theory called monetary approach. 통화론자들 in Korean jargon, Chicago economics, right? School of economics, or the school of thoughts from Chicago, Minnesota, and Carnegie Mellon. Minnesota is where I am from, right? All these schools are located around the Great Lakes, right? 담수학파. So we call them the schools around the Great Lakes. And these guys are strong believers of market efficiency and then rational expectations and every, kinds of mathematical economics and all these kind of things, popped up over there. Now, based on two basic tenets, right? These guys were arguing it. Those two important elements are purchasing power parity, and then the second one is quantity theory of money, 수량학파. What the heck is that? 수량학파, just wait for that. By the way, interesting thing is the quantity theory of money, originally actually, you can trace back the ancient form back to this guy. Who is it? Copernicus. Copernican revolution, is that guy? And the answer is yes. Wow, what the heck? We're going to get back to that idea later on. And Chicago School of Thoughts, right? Milton Friedman, right? We trace back over here, okay? And what's the idea over there? The price level, right? I told you in PPP, right? The foreign exchange rate between these two countries is, all about the price level differentials, right? So the price level of one country is a function of three different things. One is money supply, two is velocity of money, three is the national aggregate output, GDP, okay? Nominal GDP, by the way. And money supply, M1, M2, whichever one you call it, but usually M2 they say the cash or whatever, the expansionary money supply versus contractionary monetary policies are like those kind of things gets in over here, right? How much money do they print, right? And supply to the economy, pumping the money. And then even if you print those monies, right, 신사임당 or 5만 원권, 50,000 Korean won cash, right? You check it out, right? The Bank of Korea, if they print it out, so many of them, even if they print it, money supply increases, but what for if the people don't use it in a transaction and then just keep it under their mattresses, right? Or in the 장롱, right? Or keep it into their vault somehow and never use it for any transaction. The velocity of money gets zero. No good for the economy. Well, for the economy to be more lively, you have to make more transactions. The people have to buy some more coffees like me, or waters, or buy some materials and goods and services. Otherwise, right? Nobody will be transacting. Nobody transact anything. Then all the business will go down, go bankrupt, right? That's no good for the economy, right? So money has to be supplied and then has to be circulated somehow. But a lot of money being printed, that creates inflation. And then with the same amount of money, you have more velocity, right? Highly, transacting back and forth with the same amount of money, that can also create some inflation as well. At the same time, the third element is the GDP, economic size of it, right? If the GDP or economic size of the country is huge, then money supply, impact of money supply or the velocity of money upon the inflation rate will be smaller because the economy is big enough to take care of, deep enough, right? So there's an inverse relation between the price level and the GDP over here, okay? That's a basic framework coming from quantity theory of money. But where does this division relation come from? And then, just wait for that a little bit, okay? Multiplying and dividing, who says that? Hey, you may wonder, but just a minute. And then here I talked about number one equation, that's the price level of United States, maybe your home country. And then let's take a foreign country, British pound, London, right? Or Britain. The same thing, price level of Britain should be a function of money supply and then velocity of money and inversely related to their GDP or nominal GDP, right? That's the idea. Now, given the two price levels, right, we can hypothetically think about the FX rate between these two countries, right? Using the purchasing power parity relations, right? So S, let's define S as the FX rate between these two countries. And then that's nothing but P dollar over P pound, right? That should be, okay, just you saw in equation 1 and 2, MVY relations like that, right? The big ratio like this, right? Now you can do the math, right? The numerator, denominator over here, and then the numerator, denominator over there, and then the denominator should be numerator, and then the denominator of the numerator should be denominator. Yes, that's one last twist over here. So this enables us to analyze FX rate between two countries, okay? US and UK in this example. What matters in FX determination are, one, the relative money supply. That's this guy. Money supply differentials, right? And then the relative velocities of money. That's this guy. And then relative national outputs, right? Like this. Three different fundamental components there that's determining or explaining FX of two different countries. Okay, this is one model, one of the many models you could say, but this is very important one. So other things being equal, or ceteris paribus in economics. You say ceteris paribus to economics professor, they will say like, whoa, he knows economics. He is promising guy. One of the buzzwords to impress professors. Ceteris paribus, okay? Other things being equal. What can you tell based on this relation? Relative to UK, an increase in US dollar supply or an increase in the velocity of US dollar, okay, that will create the inflation more in the US rather than the UK, right? The US dollar will accordingly depreciate because there is more inflation that we expect, right? Number two, an increase in US GDP, okay, will be followed by US dollar appreciation. US GDP, right? The economic size of the US goes up. The US gets stronger. Dollar gets stronger together with it. Make sense? Yes. So that's the intuition based on this mathematical relation coming from quantitative theory of money. Remember this guy? Right. Okay. Fine. Then long run theory of this is a long run theory of FX determination, not a short term one. Okay, day by day, yeah, many things can go on, but in the long run, right? Assumes prices are just fully and completely reflecting all the relevant information. There, efficient market hypothesis, right? You can see that information, the keyword coming in. Yes, it's actually not realistic in the short run, and it holds in the long run. And why is that the case? In the short run, why doesn't it hold? Well, some of the culprit is because of price rigidity. Your labor cost, right? My salary, I want it to be fixed or increase or not decrease, right? And then the labor union works together with you so that the price of labor cost will be rigid. Okay, sticky labor cost is there. That's just one of the elements in the short in the economics determinants, right? Likewise, a lot of things are more rigid than not. Okay, and then take the natural log. By the way, okay, starting from here. I'm trying to go back to the what you've seen in your textbook about the fundamental method of forecasting foreign exchanges in your page 172, equation 6.19. Okay, of course EMH holds true, and then so that the fundamental approach will not work, right? That was our key message. But to talk about that idea of fundamentals approach, how do you really actually work with the fundamentals approach to predict foreign exchange, if you could ever, right? Even though EMH defies that. Where does that equation come from? 6.19. I'm trying to get there with this one. Okay. Take the natural log of the slides, both. Take the natural log of both sides of equation 3. Okay. Equation 3. Yes, this guy, that one, and that one. Take the natural log like this. So left hand side ln s equals ln these whole ugly terms. Holy cow! Don't worry. Okay, why? Because natural log, you know the log relation, right? What is convenient about log is this is a good, nice converter from division or multiplication into subtraction or addition. Okay, so natural log of everything will decompose all these things into one by one. So money supply of dollar log minus money supply of pound log plus velocity of money in dollar minus velocity of money in pound, all in natural log, plus GDP in pound minus GDP in US, right? So equation 4 takes place like this. Now, using equation 4, obtain what you can do to do a fundamental analysis or prediction, right? How can you do it? Well, you need a data, historical data, to estimate equation 6.19. Obtain historical data and run OLS regression like this. So small s is just a natural log of big S, the FX rate. And then it's going to be like alpha, the intercept term, where it crosses the horizontal, the vertical axis. And then beta 1, 2, 3. You have 1, 2, 3 explanatory variables, and then there will be a coefficient estimates, right? Now, what are those explanatory variables? The relative monetary supply, the relative velocity of money, relative GDP, okay? And then the natural log version of it, right? Is exactly this guy. It's exactly this guy. We just label this as small m, this guy as small v. Yeah. And then this guy as small y. That's it. Yeah. So that's this, right? And then epsilon, that's a random white noise, right? And then etc. Estimate these beta 1 to 3 alpha over the period of your data. Let's say 1980 to 2008. Did I say 10? I should have said 20. Right, 20. Then bring the forecasted values of these each different variables in 2021. Okay, your job is to predict the FX rate at the end of 2021. That's why you see what I'm saying. The estimation window is from 80 to 2020, and you want to predict or you want to forecast what's going to be the FX rate over here. For that purpose, first of all, you estimate with this estimate alphas and betas using these data, and then throw in the forecasted values of these in 2021. And then if you stick in like this, then you will be able to compute, you will be able to estimate FX rate of these two currencies. That's going to be a log version like this. So what do you do in the end? Well, to get to the FX rate predicted like this, you have to undo the natural log, which means take it to the power of e to the power of s of e 2020 like this. Okay, whatever you got in this number, take it to the power of natural log, right? Like that. So that's going to be your FX rate later on. Anyway, so that's how we do it in the fundamental analysis part to predict or forecast FX rate. But the key idea in EMH, it says it's not going to work. Okay, no matter how you predict precisely, you will not make money out of it. EMH idea, all the fundamental related information is already reflected in the FX market right now. Okay, right now. No forecast power of fundamental model. Okay, forecasting power. Of course, the beta estimate will be there significantly, and the R squared will be significant. But what I'm saying is your out of sample prediction will not work. Okay, that's out of sample sense, right? That's what we are talking about. If you so desire the fundamental model, you have to forecast those right-hand side variables, which would be subject to errors. 2021's money supply, God knows how much we will do it until December 31st, right? And then velocity of money, how do you know? We don't know. We just have some good guesses with random errors in there. And then GDP, where would it go? I don't know, right? We have to forecast those things in the first place. It's going to be noisy. Now, the parameter estimates, alpha hat, beta 1 hat, 2 hat, 3 hat, would be noisy and change over time. What I'm saying is these alpha hat, beta hat estimates will be one thing if you do the regression up until 2019. And as you include the data in 2020, these estimates would slightly change. And having said that, 2020 was such a special year. We had COVID-19 pandemic, so that these coefficients will be drastically affected. I'm afraid it's going to be a lot noisier from now on. So all these estimates are noisy, so we have to be careful. Changes over time as economic structure like government policy, monetary policy changes, and then economic shock like pandemic. The model itself could be wrong. This is one of the many models that we use, right? As an economist, it's just one of many models, right? So it's not a religion. By the way, one more extra appendix that is not in the textbook, but I just go extra mile, is a quantitative theory of money as just a pictorial explanation. Recall, right? Recall in physics, You know, one thing is that Copernicus, he's a physicist or astronomer, right? But why does he do it? Did he propose some kind of quantitative theory of money? That's an interesting point, right? But physics and economics has a lot of similarity there. Ah, why? Wait one slide. But before the physics, just a reminder. You remember this triangular relation? Time, velocity, and distance, right? 시, 속, 거. What do you mean? Time, whatever let's say one object like this guy, okay? Moving from here to there, right? What's the distance that this guy traveled? Well, that's the time it took, and then the velocity, the multiply it by the velocity that it was moving, right? Time by velocity equals distance, right? The work it did over a certain time at a certain rate, there is a multiplicative relation like this, right? And then you can play with this so much so that as long as you know the distance that one thing traveled, and then as long as you know how much time it took, you can figure out the velocity by dividing the distance by time. Okay, another thing that you can play is, as long as you know the distance that it went, and then you know the velocity of the object that, you know, it moved, then you can figure out how long it took for the material to move by dividing distance by velocity, right? That's triangular relationship that we all memorized during our teenage days, right? The funny thing is, interesting thing is, money is like water. Money is like water. So a lot of fluid dynamic kind of physicist ideas can be applied to money and economics, right? That's why those engineers and physicists and mathematicians are doing great job in finance world. And that this is another point that non-engineering guys or 문송합니다 guys, right? You guys have to familiarize yourself with this physics idea, basic concepts, and I'm trying to create this kind of opportunity for you. Now, so similar idea is applied here, right? How much of a country did their job, right, over a period of time, and then how much was produced, right? That's nominal GDP, right? And then that's something you can figure out as long as you know the money supply and then the velocity of money, right? The GDP is nothing but the economic activity, right? I'm not saying that money is everything in the world, but money is a nice tool to summarize the economic activity. And then how do we summarize this economic activity of production? Well, how much money is being printed and supplied to the system, the economy, and times the velocity. How fast did it go from one guy to the next guy, and then like that, right? Just like the distance and then time and then velocity relation like this. So who do we see over here? Well, Milton Friedman on your right hand side, and then left hand side is Irving Fisher, Professor Irving Fisher, I told you before. And then, so quantitative theory of money assumes that money supply divided by nominal GDP, okay, money supply divided by nominal GDP should be a constant, K, German word of constant, constant. It's just there. M over Y in the long run. That's their idea, first of all. In fact, it is not constant, but rather stable. Instead, let's call the reciprocal, which is Y over M. Hey, wait. Did I say reciprocal velocity of money? Okay. Yeah. So that will be velocity of money should be equal to y over m. Yeah. And then the constant, we keep it over there, right? And then if we do the math, take the y to the other side of the equation, we see this relation, m equals ky. And then what's the differential, right? Over time, money supply may change. That's delta m. Money supply in last year and the money supply this year. What's the change? The amount of change is delta. Okay? And then this one should be the change in ky. And remember, k is a constant, but y, the GDP, changes over time. So we can see that the right hand side will be k times the change in GDP or change in y. Okay? Now what do we do? Well, this is the dollar amount of changes. Okay? What we want is the rate of change instead of dollar amount of change to find out some economic relations. Okay? So what do we do? Divide equation 2 by equation 1. Right. So this guy and that guy. So this guy divided by that, that's this. Delta m over m should be equal to what? K delta y over ky. And you know k cancels each other out. Now delta y over y is there. Ooh, differential. Okay, we can see some differential equation here. To keep k constant, if m increases by 10%, the intuition is here, right? If m increases, money supply increases by 10%, right? GDP should increase by 10% as well. That's this intuition. Okay. And thus, the rate of increase in money supply should be equal to nominal GDP growth rate. That's what this equation tells us, right? Now, if we move down, but remember in your macroeconomics, nominal GDP growth rate should be equal to real GDP growth rate plus inflation rate. That's where the Fisher comes in, right? Irving Fisher. Yeah. So the rate of change in money supply should be the rate of change in GDP. And then this one is nominal rate of change in GDP, right? Nominal rate. We want to decompose into real GDP change, the rate of real GDP, the rate of GDP change. And then inflation rate, okay, pi, i.e. pi should be, okay, pi, if you keep this guy and then send this guy to the other side of the equation, right, to the other side of the equation, it will be like inflation rate being equal to rate of change in monetary supply minus the rate of change in real GDP. Oh, okay. The intuition is that inflation is the gap between the growth of money supply and the growth of real GDP. I see. Holding real GDP growth constant, right? Let's say they don't change. This is zero. Only you print more money, then inflation will take off. Okay. And then another thing is even if you print a lot of money, number two, even if you print a lot of money, if the real GDP grows very fast, right? Very fast, then what happens? Inflation is nothing to worry about. That's quite similar to the current argument about the concern of inflation. The central banker of the United States and around the world, the investors in the market have been worried about, what if inflation goes up like crazy because you printed up so much money? They say, the central bankers say what? Don't worry, the real GDP growth will be super high so that you don't have to worry about the inflation too much. That is one defense. Okay, fine. That's the idea. Another intuition we can infer from it is about Bitcoin. Remember Bitcoin, people say this is a deflationary currency. Why? Because what's the money supply of Bitcoin over here? Bitcoin? Well, it's capped at 21 million coins, Bitcoins to mine, right? Of course, there's a half-life so that you by and by reaches that, we reach that 21 million, right? But essentially this tells us that the money supply in Bitcoin economy will be near zero. And then as long as the real GDP is growing, okay, not shrinking, the inflation rate will be negative, which means deflationary. So you see that intuition? So mathematics, well, don't be scared, okay? This is just one way of analyzing the situations in a very systematic manner. It tells a lot of good stories, okay? Now, the summaries of these chapters are written in a very self-evident manner, so go ahead and read it. So this is the end of my presentation of chapter 6. So thanks for watching, and make sure you like and subscribe to subscribe to my channel. Thank you for watching, and then see you next class. Bye bye.